Chemistry, we're moving on to lesson 12. The subject is electronegativity, subject closely related to the last topic of ionization energy. So electronegativity is how much an atom wants to pull an electron towards it, either from an atom to which it is bonded or from an outside atom. Electron affinity is the energy released when an atom brings in an electron from the outside. The two concepts are closely related, but we're only going to be dealing with electronegativity. So electron affinity is an energy measured in joules or kilojoules, and in this class we will only refer to the electronegativity of an atom, so you will not hear the term electron affinity. Okay, so electronegativity is how much an atom wants to pull an electron toward it, either from an outside atom or from an atom to which it is covalently bonded. We'll learn about bonding in the near future. So here the man is inside the atom. He represents electronegativity. And electronegativity wants to pull in an electron from the outside. So electronegativity and ionization energy are somewhat related in that they both have to do with pulling in electrons. Ionization energy is how much an atom wants to pull on its own electrons, how hard it pulls on its own electrons, how much it wants to hang on to its own electrons and not give them up. That's ionization energy. Electronegativity has to do with pulling on electrons from another atom or just free electrons from the outside. So it has to do with bringing in an outside electron to the atom. So there goes the electron and it's been pulled in. So electronegativity is measured on a scale of 0 to 4 called the Pauling scale. Fluorine has the highest electronegativity of 4.0. So your reference sheet packet contains a periodic table of electronegativities. Fluorine has the highest electronegativity at 4.0 on the Pauling scale, and there you can see the electronegativities of all of the elements. The upper right hand corner are the highest, the lower left hand corner are the lowest. So electronegativity increases as you go up a group and to the right in a period. So it's exactly the same trends as ionization energy. The elements in the upper right hand corner have the highest electronegativities. They're the most likely to want to pull in electrons from the outside. The elements in the lower left hand corner have the lowest electronegativities. So this is the same pattern, same trends as ionization energy. Electronegativity is greatest in the upper right-hand corner of the periodic table where fluorine is. So lowest electronegativities in the lower left, highest electronegativities in the upper right. The elements on the right side of the periodic table, if you look at your periodic table, are called noble gases. And noble gases have no electronegativity. At least the smaller ones don't. The larger ones do a little bit, and we'll get into that later. So lowest electronegativities on the lower left, highest electronegativities on the upper right. So here's the reasoning. Noble gases already have full valence orbitals. For this reason, noble gases do not want to pull in additional electrons, and therefore, generally speaking, they do not have any electronegativity. No desire to pull in an outside electron. So electronegativities are highest when an atom has fewer orbitals and 2, the nucleus has more protons. This is exactly what you saw when we talked about ionization energy, so we'll say it with respect to electronegativities. So lithium has a lower electronegativity, lithium being on the far left over there, a lower electronegativity than fluorine on the far right because it has the same number of orbitals, 2 orbitals, but fewer protons. So lithium doesn't pull in electrons as well as fluorine. Bromine down at the bottom there has a lower electronegativity than fluorine because bromine has more orbitals and more core electrons. The electrons outside of the atom are screened more from the nucleus, so the atom, that is bromine, can't pull in electrons as well. So again, the trend is as you go from left to right across a row, the driving force is protons, number of protons. Fewer on the left, more on the right, so the atoms on the right side of the periodic table will pull in electrons better, will have higher electronegativities. Going up and down a group, the driving force is the number of orbitals. Bromine has so many orbitals and so many electrons between the nucleus and outside of any electrons outside of the atom that it's not going to pull in those outside electrons at all well. So bromine has a lower electronegativity than fluorine. So fluorine is the highest possible electronegativity. It's ranked 4.0 on the Pauling scale. And that takes care of this lesson on electronegativity. And in the next lesson, we'll go on to a related topic of atomic radius.